This story began with a group of American researchers who decided to do something regular folks wouldn't even dare to think about. While most people, quite rightly, fear hurricanes, try their best to stay far away from them, and pray they don't come too often, the heroes of our story were actually waiting for their storm. Because the kind of storm they needed doesn't come around every day. On October 10, 1947, word came from Miami, Florida that a promising storm was forming near the Swan Islands in the Caribbean. The researchers' plans kicked in right away, and by the next evening, 2 B-17 planes were already in Mobile, Alabama. They were about to face the first ever attempt to change a tropical cyclone and tame a force of nature no one had ever managed to control. Well, as for us, we're about to find out what came of it. But first, coffee. Here's an unobtrusive reminder to do that thing under the video in case you forget. So the planes were in place and getting ready for takeoff. But the storm, which people had been waiting for so long, was moving so fast that by then it had already crossed Florida. On October 12th, the hurricane, named King by the Air Force Hurricane Center, headed northeast, dumping tropical rain on the southern tip of the peninsula. This caused a devastating flood that lasted for several days. 2 days later, the hurricane moved out into the Atlantic. According to all the forecasts, it was supposed to stay over the ocean and not hit land again, putting no one at risk. And that made it the perfect subject for testing. It was time to get started. The mission involved 2 B-17s and 1 B-29. All 3 planes took off from the airfield and headed east with one clear goal: to intercept the hurricane. The job of the first B-17 was to fly along the upper edge of the clouds and drop something into them, specifically large chunks of dry ice, which had been loaded into a crusher on the plane and then dumped into the clouds. The second B-17 had an easier job: stay 2,600 feet behind and 2,900 feet higher to record how the clouds were changing. As for the third plane, it handled command duties, kept an eye on the changes, and directed the other 2 planes. So on the morning of October 13, 1947, a Boeing B-17 loaded with 180 pounds of crushed dry ice took off from MacDill Field Air Base in Tampa, Florida. Following the plan, it caught up with the storm and climbed 500 feet above its dark upper clouds, and the crew showered the storm with thousands of little white pellets of dry ice, that is, frozen carbon dioxide. This is what the storm looked like: an eye about 30 miles across in the center and a thick wall of clouds around it. The eye of the storm is a calm area right in the middle of a tropical cyclone where the air pressure is usually way lower than outside the storm. The plane didn't have any sophisticated homing equipment, so they decided not to fly into the hurricane's eye or heavy rain bands, but to dump ice into the outer clouds instead. It all happened in a few stages. First came a half-hour flight covering 109 miles, during which they dropped the first 79 pounds of ice. Then it turned to see what had happened, and 2 more big dumps of 50 pounds each. Both of those landed in one big cumulus cloud top, after which the plane flew away again. People noticed that after the first drop, the cloud layer below started to break up. After the second, the cloud top kept growing. Satisfied with their efforts, all 3 planes headed back to base. However, that was just the beginning of the work, and the scientists were eagerly waiting for the chance to study the storm the next day. But when they flew to the expected storm location, they had trouble pinpointing its center. It took some time to find it. The center turned out to be about 99 miles away from the expected spot. The storm, drifting northeast, made a 135-degree turn to the left. It was unexpected and totally out of character for any cyclone. But to understand how this happened, we have to look into the project's core. It all started inside a $240 home freezer at General Electric's research lab. In 1946, Irving Langmuir and GE mechanic Vincent Schaefer built a freezer with an open top to mimic the cold upper layers of the atmosphere, where they hoped to create precipitation. They lined the freezer with black velvet to make it easier to spot any precipitation. Icicles the size of carrots lined the top edge. To create snow, Schaefer would breathe into the chamber. Schaefer and Langmuir were working hard to create realistic precipitations. Water usually freezes at 32 degrees Fahrenheit, but it can also remain as supercooled vapor, hanging invisibly in the air at lower temperatures. Eventually, progress came to a halt on a hot July day when the heat prevented the freezer from cooling properly. To continue his experiments and lower the temperature, Schaefer went to the nearest lab and borrowed a block of carbon dioxide, which freezes at negative 109 degrees Fahrenheit. When he dropped the block into the chamber, he suddenly noticed a bluish mist. The temperature had finally dropped enough to bring the vapor out of suspension, and when Schaefer exhaled, ice formed instantly, thousands of tiny droplets that shimmered on the black velvet like diamonds. Clouds in the sky are also suspended water molecules, which only fall as precipitation when the water clumps together into heavier drops or ice. The freezer experiment gave an idea of how to speed up this process. Shortly after that, a second breakthrough occurred. Dry ice has its limitations. It needs to be supplied in small, careful doses so it doesn't choke the steam clouds or interfere with ice formation. That's why another assistant, Bernard Vonnegut, created ice with silver iodide. Silver iodide crystals have the same structure as ice and can trick water molecules into sticking. The thing is, while purified silver iodide was more effective than crushed dry ice, it was harder to make. After these breakthroughs, Langmuir's colleagues started new experiments, and soon they reached the first cloud seeding in November 1946. General Electric rented a Fairchild 24 plane, and during the flight, Schaefer identified a high-altitude cloud 4 miles long at 13,800 feet. Flying over it, Schaefer slowly dropped just over 2 pounds of crushed ice through a funnel. According to witnesses, the cloud writhed in torment and within minutes turned into snow. But more experiments were needed. This is how Vincent Schaefer decided to try to fix aircraft icing because it posed a real danger to people. In 1946, while studying ice, the atmosphere, and air, he discovered that adding a frozen element to clouds like dry ice or silver iodide could make supercooled water freeze into ice crystals. These crystals would bounce off the metal, thus eliminating the threat of ice buildup on the wings. It didn't take long before the experiments at General Electric caught the attention of the government. Eventually, along with the company, various branches of the government and the military formed a coalition called the Cirrus Project, and Irving Langmuir headed it. This was the time after World War II when science could do anything. No one thought about what would happen if a hurricane was seeded. They just decided to do it. So the Cirrus Project has been launched, supported by the U.S. government, and focused on figuring out how to stop deadly hurricanes. And with that support, the scientists got their hands on some serious aircraft. What were they trying to do? In short, seed the hurricane clouds with dry ice, hoping the ice would interact with the clouds and destroy the cyclone's internal structure. The cyclone would weaken and become less deadly or maybe even fizzle out completely. Basically, the goal was noble, except for one thing. It was totally unpredictable. Hurricane King, gaining strength, rushed toward the Atlantic coast. By noon on October 15th, it hit Savannah, Georgia, damaging the area for many miles inland and causing $23 million in damages, or $220 million in today's money. Several people were killed. South Carolina also took a hit. It brought tides up to 12 feet, and in Savannah, 1,500 or more buildings were badly damaged by wind gusts reaching 95 miles per hour. Not long after, the media started reporting that the hurricane had been seeded before the tragedy. The military denied the experiment had stirred up the storm, but commanders refused to reveal flight details or scientific data. Outraged residents of the affected states threatened to sue. Irving Langmuir, of course, felt for the victims, but still believed that people had finally found a way to control the weather. In a 1948 Fortune magazine article, he bragged, "There is a reasonable probability that in 1 or 2 years, man will be able to abolish most damage effects from hurricanes." He also made a statement that he was 99% sure the storm changed course because of the seeding. Chief of the Weather Bureau, Dr. Francis Reichelderfer, disagreed and assigned 3 of his meteorologists to find a case where a hurricane followed a similar path but wasn't seeded. A case was found, and the info was published as proof that hurricanes can shift course like that on their own. Threats of lawsuits slowly faded away, but so did the public's excitement about weather modification. The Cirrus Project was pretty much shut down before it even got off the ground, and any research into hurricane control was dismissed for decades. A hurricane in Savannah scared General Electric's legal team so much that Langmuir went off to New Mexico and started seeding clouds with silver iodide smoke. That is, not fighting hurricanes, but making it rain. The work went on for about 2 years, caused a few downpours, and one of them stretched across 3,800 square miles and dumped 200 billion gallons of rainwater. There's no way this could have happened naturally, Langmuir insisted. The scientist ended up on the cover of Time, was dubbed the Rainmaker, and eventually even quit his job at General Electric to promote cloud seeding. Sensing a quick profit, private pilots rigged their planes with cloud seeding gear and started working the skies in 6 states. But for every ranch owner or city water engineer eager to seed the clouds, there was a farmer or hotel owner fuming over hail and bad visibility. In 1952, U.S. Senator from Michigan Blair Moody promised to launch a congressional investigation since a string of rainy weekends supposedly caused by hail, according to Langmuir, was hurting Michigan's booming tourist business and ruining a lot of picnics. Basically, while meteorologists were rejecting and debunking the very idea of cloud seeding being real, Langmuir kept insisting otherwise. He died in 1957, but even after the champion of weather modification passed, his cause kept going strong. When it came to hurricanes, nobody really did anything until the mid-1950s, but then there was an insanely active hurricane season with many of them hitting the land, and Congress decided to put more money into research. They also launched the National Hurricane Research Project. It had 4 main goals: to study how hurricanes form, to understand their structure and dynamics, to find ways to improve forecasting, and to figure out how to modify hurricanes. That last goal kicked off Project Storm Fury. Storm Fury was an ambitious experimental project focused on hurricane modification. It ran from 1962 to 1983, and the main goal was to hunt down hurricanes and wipe them out, or as the scientists called it, modify them using planes and silver iodide seeding. In total, modification was attempted on 4 hurricanes over the course of 8 separate days, and for the pilots, this experience was, let's say, something special. Few storms rattle an airplane like a hurricane. There were some times when the turbulence got so bad that I thought, damn, I maybe misjudged this one, recalled David Turner, a former Storm Fury pilot. The turbulence is a rolling, boiling kind, said Turner, and we could see Zippo, just gray streaks of clouds and rain. There was a roaring, hammering of the rain on the airframe, a wild roar, and then the plane would burst into the eye of the storm. Not every flight went through the eye, but pilots definitely remember the ones that did. Some of them describe it as coming out of a dark cave of clouds through sheets of water like a waterfall, and then the plane hits clear, gleaming air. The wind dies down and gives the pilots a moment to catch their breath, get the plane back in shape, and then dive back into the storm. Even though the first official hurricane seeding happened in 1961, the first one considered a success took place during Hurricane Beulah in 1963. That time, wind speeds dropped by almost 20% as silver iodide broke down the storm's eye wall. Still, the results weren't totally convincing. More proof was needed to confirm the idea that seeding could really affect a hurricane. No other seeding happened before 1969, but that didn't mean Project Storm Fury was doing nothing. Instead, the researchers focused on improving the equipment, and when Hurricane Debbie formed in 1969, Project Storm Fury was ready. The seeding turned out to be a success. Over 10 years, from 1961 to 1971, scientists seeded clouds in just 4 hurricanes. The experiments were carried out over the open Atlantic, far from land, and they managed to cut wind speeds by 10 to 30%. Thing is, that only happened 4 times. Lack of response on other days was interpreted as a result of incorrectly performed seeding or poorly selected subjects. Storm Fury's yearly budget of $2 million topped Cirrus's $750,000 at its peak, and that's not even counting the millions spent on outfitting the planes. Instead of dropping the substance through funnels like they did in Cirrus, some Storm Fury scientists came up with 130-pound bombs. On top of that, they built plastic rockets a few inches wide called candles. These had a delayed fuse and released silver iodide for 36 seconds as they fell. It's possible that more seeding operations would have been carried out as part of the project, but all actions were only taken if the storm met a long list of criteria. For example, the hurricane had to have less than a 10% chance of reaching land during the day, be within the range of the seeding aircraft, and be an intense storm with a well-formed eye. It quickly became clear that it was too difficult to find suitable cyclones for the task, and to prove the hypothesis, several hundred experiments would need to be done. Where do you find that many hurricanes? However, scientists were sure they'd finally developed a foolproof way to neutralize hurricanes. The logic was pretty simple. Even though hurricanes can stretch for hundreds of miles, they concentrate their fury in the eye wall, a group of clouds swirling around it. Even in the most powerful storms, this area covers only a few dozen miles. The denser the eye wall, the higher the energy concentration and the more damage when storms hit land. Storm Fury scientists calculated that if they scatter silver iodide in a wide ring around the eye, the seeded clouds will release rain and break apart. This will disrupt the eye's wall and reduce wind speeds. Since the amount of damage a hurricane can cause largely depends on the speed of its winds, even the slightest decrease could potentially make a huge difference. That's why the researchers at Storm Fury spent over 20 years working. Their goal was really important. Because of the scale, each planning required around 10 planes to fly in circles for an hour or two in total darkness with strong turbulence under streams of water. This required perfect coordination. But the pilots could do it, and the scientists knew exactly how many planes had to fly and at what distance from each other. They knew which chemicals to spray, how much, and when, and what kind of storm they needed for it all to work. Unfortunately, this turned out to be a fatal flaw. Observations made in the 1980s showed that most hurricanes didn't have enough supercooled water for the Storm Fury seeding to work. Over the years, science became more objective and rigorous, and support for hurricane seeding among scientists weakened. Blind experiments with non-thunderstorm clouds where pilots randomly tore open one of two sealed envelopes containing instructions to either seed or just pretend to seed showed that scientists on the ground couldn't reliably tell if the clouds had been seeded. In the early 1970s, the Storm Fury project came to a halt. When scientists tried to revive it a few years later, politicians opposed it. Moving hurricane seeding to the Pacific Ocean didn't work either. China, Japan, and Australia flatly refused such experiments. The deadly blow to Storm Fury came in the early 1980s, when 3 graduates of the project wrote a demoralizing scientific analysis. They concluded that hurricanes were always destroying the walls around the eyes and building new ones with or without seeding. The analysis also showed that the amount of supercooled water in hurricanes, which is a necessary ingredient for seeding, was far less than scientists had thought. In general, seeding probably didn't destroy a single hurricane, and any observed reductions in wind speed were random. In 1983, the U.S. Department of Commerce officially shut down the Storm Fury project, and you can see where the department was coming from. It's nearly impossible to tell the difference between the effects of seeding and the natural changes hurricanes go through. The project went on for over 20 years, but Storm Fury never managed to completely destroy a single hurricane. As for the present day, the main focus of the Hurricane Research Division at the U.S. National Oceanic and Atmospheric Administration is studying hurricanes and improving forecasts. The authorities believe the best way to minimize hurricane damage is to learn how to live with them. It's important to follow proper building codes and understand the risks when choosing to live in a hurricane-prone area. You also need to prepare wisely and raise public awareness. And of course, forecasting needs to get better too. All of that can help when a hurricane inevitably hits the land. Yeah, the goal of taming hurricanes and steering them really was thrilling, but the failure of Project Storm Fury showed that it's still out of reach. Still, a lot of what came out of the project left a legacy in how we understand hurricanes. Developing tools, studying cloud dynamics, running simulations, all of that grew thanks to Storm Fury. On top of that, the project kicked off a bunch of institutions and approaches that now form the core of modern hurricane research. All the collected observation data has really expanded what we know and understand about hurricanes. Partly thanks to it, we're now able to predict hurricanes way better than 70 years ago. You owe me a like. See you later.